All right, hey everybody. This is a demo of my final project, and as a reminder, I'm doing a fall detector, and that is because my grandpa had a fall during the course of this class, and I wanted to have something that could help with that because he lives with my grandma, who's also old and can't really help him that much, and I wanted something to be able to alert people whenever that happens so that they can get some help. So I'm going to start with the demo, and then I'm going to move into some of the code behind it. So you can see on the screen right now, I'm using PoseNet and it's getting all my joint points, coordinates, and plotting them over the image. And whenever I fall, there'll be a text box that comes up under the words that say fall detector 3000. And then on the console on the right, it'll show you some information. So I'll just move around to show you that it doesn't trigger when I'm just wandering around on the canvas. Then I'll drop really quick. You can see like a fall happened, and it's showing some of the output over there on the console. The information it's displaying is the mean square error, so that's what I'm using to detect the anomaly, as well as the quantile. So that goes into like figuring out like, is the mean square error greater than the quantile? We'll get into some of that in the code here in a second. So I'm gonna go ahead and turn this off, save my CPU some. Kill that server. All right, cool. So now we'll walk through some of the code. All right, let's start with the HTML. That's where everything's being imported at. So most of this, like, there's not really any HTML at all. It's just the title, the H1 of the page, and then this fall alert. So that's where it says a fall has occurred or a fall has been detected. And then that's manipulated through JavaScript. On the PoseNet file we'll get into here in a second. These are importing a few different things. This first one is getting the D3JS library, and that's what I'm using for the quantile function. We have some TensorFlow libraries and model libraries, and then this PoseNet.js, which is a file that I made. So we'll go ahead and look at that. And here we're just getting some variables for video with PoseNet, stuff like that. My function for mean square error, this is the DQ thing that I copied basically from Python. This is a JavaScript implementation of it. That's for me to have a array to put these values in that I can pop off the last one and insert at the front of it. All right, so here is where we are getting the video and drawing that canvas on the screen. Here's where we are loading in the model. So I will go to, that's the PoseNet model that we're loading in. This model path here, fall detector, that is one that I made in Python. Let's go ahead and switch over there and show you what the anomaly detection model looks like. So for the anomaly detection, I'm only looking at the left shoulder Y coordinate and the right shoulder Y coordinate, because I don't really care if you're moving left or right. I only care if you're going to have a sudden drop in your Y axis. So I'm only using that, and for my data, I just randomly generated some values based off of a couple data points that I saw when I was going through the JavaScript video, some of the PoseNet models, PoseNet values that it returned. Then I'm just doing a really basic autoencoder here, like just a couple layers, one encoding, one decoding, and then an input-output. Yeah, just very basic model. Then I'm writing that out to a file that can be read into JavaScript. So let's jump back over here to the JavaScript part. Cool, so we have both the PoseNet and the fall detector model loaded in. This is using the PoseNet to get the different shoulder points. So X and Y, I can actually comment out X at this point. I started with it, and then I decided just to use Y, so I should go back and clean up that code. So it's grabbing those Y coordinates for both the shoulders, and then we're going to use the model to predict. So I'm getting the predicted values, and then I'm measuring the mean square error on those values. And that's what this mean square error value is. Then I'm just keeping the list of 100 values, and then I'm doing the quantile on that list of 100 values to get basically if it's over that quantile, then consider it an anomaly. If it's less than that, consider it a normal data point. And then here is where that logic's happening, and if it is greater than that quantile, I'm logging some stuff to the console first of all. So fall, the mean square error that's being reported, and the quantile that's causing it to trigger that mean square error. Here is where we are changing that JavaScript, changing that HTML element over here, the fall alert ID, to where it says there was a fall, and then I have that on a 5-second timeout. So after 5 seconds, that will disappear. Yeah, and then this is just drawing the joint points from PoseNet onto the screen. Yeah, so this is a pretty basic model, especially on the anomaly detection side with the autoencoder. Some stuff that I would definitely look at upgrading in the future is the data that I'm training it on. Again, like that was just random values in Excel. I would also train it on more values. I think I only did like 100, maybe 200 values. I would try a better model, maybe getting some recurring neural net in there, like a LSTM or a GRU. What else would I do? I would learn JavaScript better so I can actually know a lot better what's going on and make this a lot cleaner and easier to understand. Yeah, so that's my project. Hope you guys like it. I hope to be able to continue working on it so I can actually like deploy that on a like a Raspberry Pi or something. Right now, as you saw, this was just on my webcam on my computer. So yeah, a lot of fun working on it. Learned a ton. Like this is my first exposure to JavaScript, so I actually like JavaScript quite a bit. It's pretty close to R as far as syntax goes, so that makes me happy. All right, thanks guys.